All right, so today we have Faye Zhang of Pinterest, where she is a staff AI engineer. And so, with that, Faye, welcome to the podcast.
Thanks, Ben. Huge fan of the work. I've been fortunate to attend both the RE and NLP Summit. I know where you serve as chairs. Also, love the O'Reilly AI podcast. The recent episode on A2A and the one with Raz and Martin on Notebook LM has been really inspirational. So great to be here.
All right, so let's jump right in. So, one of the first things I wanted to really talk to you about is this work around pin landing, and you published papers. But I guess at a high level, Faye, maybe describe for our listeners what problem is pin landing trying to address.
Yeah, that's a great question. I think, in short, trying to solve this $1 trillion discovery crisis. I think we're living through the greatest paradox of the digital economy. Essentially, there's infinite inventory, but very little discoverability. Picture one example. A bride to be asked ChatGPT now, find me a wedding dress for Italian summer vineyard ceremony. And she get great general advice. But meanwhile, somewhere in Nordstrom's hundreds of catalogs, there sits the perfect terracotta silk midi dress, never to be found. And that's $1,000 sale that will never happen. And if you multiply this by 8 billion searches across Google, SearchGPT, Perplexity, we're talking about a $6.5 trillion marketing, according to Shopify's projections, where every failed product discovery is money left on table. So that's what we're trying to solve. Essentially, solve the semantic organization of all platform versus a user context or search.
So before pin landing was developed, and if you look across the industry and other companies, so what would be the default? What would be the incumbent system, and what would be insufficient about these incumbent systems?
Yeah, there has been researchers across the past decade working on this problem, and we're definitely not the first one. I think number one is to understand the catalog attribution. So back in the days, there's multitask RCNN generation, as we remember, on identify fashion shopping attribute. So you would pass in system an image, it will identify, okay, this shirt is red, and that material might be silk. And then recent years, I think because the leverage of large scale VLM, vision large language models, this problem has been much easier. And then I think the second route that people come in is via the content organization itself. So I think there back in the days will be research on joint graph modeling on shared similarity of attributes. And a lot of e-commerce store also do. Hey, if people like this, you might also like that, and that relationship graph get captured in the organization tree as well. We utilize the vision large language model and then the foundation model clip by OpenAI to easily recognize what this content or piece of clothing could be for. And then we connect that between LLMs to discover all possibility like scenarios, use case, price point to connect the two worlds together.
So to me, that implies you have some rigorous eval process, or even a separate team doing eval. So can you describe to us at a high level what is eval like for a system like this?
Definitely. I think there are internal and external benchmark. For the external ones, it's the Fashion 200K, which is a public benchmark anyone can download from Hugging Face on standardize how accurate your model is on predicting fashion items. So we measure the performance are using the recall top K metrics, which assess either the label appears among the top end prediction attribute accurate. And as a result, we were able to see 99.7% recall for top 10.
So the other topic I wanted to talk to you about is, I guess, broadly speaking, recommendation systems, right? So obviously, there's now talk about, hey, maybe maybe we can go beyond correlation and go towards reasoning. So can you give our audience who may not be steeped into the state of the art recommendation system? So how would you describe the state of recommenders these days?
Yeah, I think for the past decade, we're seeing the tremendous movement from foundational shifts on how Rexus essentially operates. I think just to call it a few big themes I'm seeing across board. Number one, it's kind of moving from correlation to causation. It's back then it was, hey, user who likes X might also like Y. But now we actually understand why contents are connected semantically. And our LM AI models are able to reasoning about the user preference and what they actually are. And I think the second big theme is probably the cold start problem, where companies leverage semantic IDs to solve the new item by encoding content, understanding in content directly. For example, if it's this address, then you understand its color, style, theme, and etc. And I think of other bigger themes that we're seeing, for example, Netflix, is that they're merging from the isolated system into a unified intelligence. For example, I think just this past year, Netflix had their multitask architecture where shared representations into one, they call it the unicore system to enable like company-wide improvement optimizations. And very lastly, I think on the frontier side, this is actually what I learned at the AI Engineer Summit from YouTube X DeepMind collaboration, where YouTube now using large recommendation model, essentially teaching Gemini to speak the language of YouTube. Of hey, user watched this video, then what might it watch next? So a lot of very exciting capabilities happening across board for sure.
But generally, it sounds like the theme from years past still map over in the following sense, right? So there's content. So the difference being now you have these foundation models that can understand the content that you have more granularly, right? So it can go deep into the videos and understand, hey, this video is similar to this video, right? And then the other source of signal is behavior, right? So what I actually respond to. So that those are still the two main buckets, correct?
Yes, I would say so.
And so the foundation models help you on the content side, but not necessarily on the behavior side.
I think it depends on how you want to see it. For example, on the embedding side, which is kind of representation of a user entity, there has been transformations between back in the day with BERT, transformer, now it's got long context encapsulation. Those are all with the help of LLMs. So we can better understand user not to next or the last clicks, but hey, next 30 days, what might the user like?
So I'm not sure if this is happening. So correct me if I'm wrong. So the other thing that I would imagine that the foundation models can help with is, I think for some of these systems like YouTube, for example, or maybe Netflix is a better example. Thumbnails are important, right? So the fact now that you have these models that can generate multiple variants of a thumbnail on the fly means you can run more experiments to figure out user preference and user taste, correct?
Yes, I would say so. I was lucky enough to be invited into one of the engineer network dinner, spoken with the engineer who actually worked on the thumbnails. They apparently it was all personalized, and the approach you mentioned enabled their rapid iteration of experiments had definitely yielded very positive results for them.
So the listeners who don't work on recommendation systems, what are some general lessons from recommendation systems that generally map to other forms of ML and AI applications?
Yeah, that's a great question. I think a lot of the concepts still applies. For example, the knowledge distillation. I know Indeed was trying to tackle this kind of
So
real world.
maybe Faye, first define what you mean by that in case listeners don't know what that is.
Ah, yes. So knowledge distillation is essentially, for a model sense, learning from a parent model who had larger, bigger parameters, have better world knowledge, and same with the ML system, and to distill into a smaller models that can operate much faster, but still hopefully encapsulate the learning from the parent model. So I think what Indeed back then faced was the classic precision versus recall in production ML. Their binary classifier needs to really filter out the bad job that you would recommend to the candidates. But this process is obviously very noisy, and sparse training data can causing latency and also constraints. So I think back in the work they publish is they couldn't really get effective separate resume content from was Mistral and maybe Llama 2 back in the days. And they were happy to learn. And then out of the box GPT-4 achieved, I think, something like 90% precision and recall. But obviously, GPT-4 is more expensive and has, like, I think, close to 30 seconds of inference time, which is much slower. So I think what they do is using the distillation concept is fine tune a GPT 3.5 on a label data and then distill that into a lightweight bird based model using the temperature scale of softmax. And they're able to achieve millisecond latency and comparable of recall precision trade off. So I think that's one of the learning we see across the industry that the traditional ML technique still works in the age of AI. And I think we're going to see a lot more in the production work as well.
By the way, one of the underappreciated things uh, in the recommendation system space is actually UX in some ways, right? Because basically, good UX for delivering the recommendations actually can move the needle. Am I wrong or not?
Oh, do you mean like how big
How
the
you actually present your recommendations might make a material difference.
I think that's very much true. Although I can't claim to be an expert on it because I know most recommendation system deal with monetization. So it's tricky to put, hey, what my user click on, like engage, uh, send via social versus what percent of the
And
ad.
it's also very platform specific, right? So you can imagine TikTok is a one single feed, so the recommendation is just on the feed. But YouTube is, the stuff on the side or whatever, right? And then Amazon is something else, right? Spotify and Apple Podcasts is something else, right?
Yes.
But in each case, I think for those of us on the outside, I think we underappreciate how much these companies invest in that actual interface, right?
Yes, and I think there are multiple iterations happening like at any day that you might see a different interface than your friends, family, because you're actually be grouped into A/B tests. I think this is very much true. Like the engagement and performance of the UX have an impact on a lot of the search rec system as well, beyond the data we just talked about.
Which brings to mind another topic that is also something I've been interested in over many years, which is this notion of experimentation. Many of the most successful companies in the space actually have invested in experimentation tools and an experimentation platform where people can run experiments at scale, and those experiments can be done much more easily and can be monitored uh, in a much more principled way so that any kind of things they do are backed by data, right? So I think that companies underappreciate the importance of investing in such a platform. I don't know.
I think that's very much true. A lot of larger companies actually build their own in-house A/B
Yeah.
testing experiment or AA testing frameworks. Meta does, Google have their own, and even within different cohort of products, if you're like monetization, social, they have their own niche experimentation platform. So I think that thesis is very much true.
So then the last topic I wanted to talk to you about is context engineering, right? So I think that I've talked to numerous people about this, right? So every 6 months, the context window for these large language models expand, right? But obviously, you can't just stuff the context windows full because one, it's inefficient, and two, actually, the LLM can still make mistakes because it's not gonna efficiently process that entire context window anyway, right? So talk to our listeners about this emerging area called context engineering and how is that playing out in your own work.
Yeah, I think this is a fascinating topic where you will hear people passionately say, quote unquote, rag is dead. And it truly, I think, as you mentioned, our context window gets much, much bigger. Like, for example, back in April, the Llama 4 has a staggering 10 million token context window. So the logic behind this argument is quite simple. Like, if model can indeed handle millions of token, why not just dump everything instead of doing retrieval? I think there are quite a few fundamental limitations towards this. I know folks from contextual AI are quite passionate about this. I think number one is scalability. A lot of times in production, at least, your knowledge base is measured in terabytes or petabyte, so not tokens, so something even larger. And number two, I think, would be accuracy. The effective, I think, context windows are very different honestly what we see and then what is advertised in product launches. We see performance degrade long before the model reaches their quote unquote official limits. And then I think number three is probably the efficiency. And that kind of align with honestly our human behavior as well. Like, do you read the entire book every time before you need to answer one simple question? So I think the context engineering is it's slowly evolved to something from like a buzzword, I would say a few years ago, into now like an engineered discipline.
Look, I mean, I think that I'm appreciative that the context windows are increasing, right? So, but at some level, uh, I also acknowledge that to some extent it also is kind of a feel good move on the part of the model builders, right? So it makes us feel good that we can put more things in there, but it may not actually help us answer the question precisely, right? Actually, a few years ago, I wrote a post, basically kind of a tongue-in-cheek post called "Structure is all you need." So basically, whatever structure you have, you should help the model, right? So if it's in a SQL database, then maybe you can expose the structure of the data, right? So if it's a knowledge graph, ex- you leverage whatever structure you have to provide the model better context. So I think this whole notion of just stuffing the model with as much information uh, for all the reasons you gave is valid, but also kind of philosophically, I'm not. It doesn't make any sense, right? So uh, to do that anyway. So what are the things that you are looking forward to, Faye, in terms of foundation models? So what kinds of developments in the foundation model space are you hoping for, and w- are there any developments that you think are below the radar in terms of foundation models?
I think to better utilize the concept on contextual engineering, there are essentially two loops. There's number one within the loop of what happened, yes, within the LLMs, and then there's the outer loop, like what can you do as an engineer to optimize a given context window and etc. to get the best results out of the product. Within the context loop, I think there are multiple tricks we can do. Like, for example, there's like the vector plus Lexel or regex extraction. There's the metadata fillers. And then for the outer loop, I think this is a very common practice. I think people are using LLM as a re-ranker, sometimes a cross encoder. So the thesis is, hey, why would you overburden LLM with a 20,000 ranking when there are things you can do to reduce it to top 100 or so? So all of this, I think, context assembly with deduplication and diversification would help our like production from like a prototype to something more real time, reliable, and able to scale more infinitely.
Yeah, to me, if one of the things I wish, and I don't know, this is wishful thinking, is maybe if the models can be a little more predictable, that would be nice, right? So, uh, by that I mean, if I ask a question in two different ways, it'll basically give me the same answer. The foundation model builders can somehow increase predictability and maybe provide us with a little more explanation for how they arrive at the answer, right? So I understand they're giving us the tokens that, and maybe some of the reasoning models are a little more transparent, but give us an idea of how these things work because it'll impact what kinds of applications we'd be comfortable deploying these things to, right? So if we have those two, for example, for agents, right? So if I'm using an agent to use a bunch of tools, but I can't really predict their behavior, so then that impacts the types of applications I'd be comfortable using a model for, right? So
Yeah, definitely. I think I largely very much resonate with this, especially now most engineer we have, AI empowered coding tools like Cursor, Windsurf. And as an individual, I very much appreciate the chain of thought, as you mentioned, why agent do certain things. Why is it navigating between repository? What are you looking? Why you're doing this call? I think these are very much appreciated. I know there are the other approach where if we look at Devon, that's the fully autonomous, your engineer peer. It just take things and you don't know where it goes. But I think in the near future, there will be a nice marriage between the two. Well, now since Windsurf is part of kind of Devon's parent company. So
yes, yeah. And with that, thank you, Faye.
awesome. Thank you, Ben.